How you going, guys? Curtis from Cutting Edge Engineering. So today we're going to be making some shop tooling. What we're going to be making is some extended arbors for our milling machine. So this is a standard 40 taper arbor for a boring head, and the problem I've got is some of our jobs are quite large, and with this arbor we aren't able to reach the bottom of the hole. So what I can do is use a extended boring bar out of the boring head in order to reach the bottom of the hole, but that causes rigidity issues, which means I have to take finer cuts and makes the job take a lot longer. And even though we do have 120 mil of travel on our quill on the milling machine, because of the diameter of the quill, sometimes it's too large for it to pass through the job. And I haven't been able to find extended arbors online or through any of my tooling suppliers, so we're just going to make some. And to make them, we're going to be using 4140 centerless ground solid bar. So the starting diameter of the bar is 65 mil, and we are going to be making 3 of them. One will be 150 mil extension and the other 2 will be 75. And we're making 2 the same size because one will be dedicated to a 50 mil boring head and the other one will be set up for a 75 mil to suit larger jobs. But then we'll also have the longer arbor, so if we do have anything that's a little bit deeper, we can just change the boring head onto that arbor. We're going to get our first one set up in the lathe so we can start machining. Now that I've got that set up, I'm going to machine the OD down to 50 mil. Now I'm going to use my radius insert to machine a radius into this corner. Next thing I'm going to do is machine and thread the end to suit the boring head. And the thread we need to machine is 1.5 inches by 18 TPI. But first we need to machine down the diameter. So that's this end machined and the boring head fits nicely. I'm just going to deburr these threads. Before I change the setup to machine the taper, I'm going to get the other two up to the same stage.
silly.
So that's our 3 tools up to the same stage. Now what I need to do is set up the lathe so I can machine the taper. And to do that, I'm going to put a 40 taper tool in the chuck, then set up a dial indicator, and then I can dial in my compound. So I know that the taper is about 8 degrees, but I'm not going to trust the increments that have been machined into my top slide. I'm going to use the dial indicator to get it correct. So I've got that dialed in. I'm just going to lock the compound in position. And the compound's actually reading about 8.5 degrees. That's the reason why we used the dial indicator. Now we're going to set up our arbor so we can keep machining. What we need to do is machine down the OD to the major diameter of the taper, which is 44.4 mil. And we're going to machine that to a length of 95 mil. Now I'm going to machine down the minor diameter of the taper to 25 mil, and we'll machine that to a length of 28 mil because that's where the taper starts. Now that that's done, we can cut the taper. Now I'm going to drill and tap the end to an M16 thread to suit the drawbar on our milling machine. So that's a lathe work completed on our first arbor. Now I'm going to get the other two up to the same stage.
Where are you going? So silly. Okay. You good boy. You good boy. I see you got chicken. Yes.
Righto guys, so that's all the lathe work completed on our new arbors. The last thing I need to do is mill in the drive slots to suit the drive dogs on the mill. So the drive slots have to be opposite each other. In order to get that correct, I'm going to be using the boring head. So what I need to do is find the center of the vise, and to do that I'm going to use an edge finder. Now that I've found center, what I'm going to use is a 12mm dowel to get the boring head in exact alignment with the quill. Now with that set up, we're going to change out to our 16mm end mill and mill our first slot. Now we've got our first slot machined, we can rotate the part, and I'm going to use the 12mm dowel to get the boring head exactly in alignment 180 degrees from the first slot. So that was really quick and easy, but an alternative way would be using a rotary table or a super indexer. Now that that's done, I'm going to use a wire wheel on a bench grinder to get rid of these burrs. So that's our first one completed. I'm going to get the other two finished off as well. Righto guys, so that's all of our extension arbors completed for about $100 in material and 3 hours to machine all of them. It was a good investment for our business and this is going to save time in the long run. And I've also had the arbors coated in the Tough Tried treatment. Not only does it look really good, but it's going to stop them from corroding and getting scratched. And there's just one more thing that I need to do, and that's get one set up in the milling machine to see how it looks. So that fits in there perfectly. I'm really happy with how these came out. You're just going to have to keep your eye out for a future video when we might be using these. Thanks for watching. Now that's done, I'm going to use a wire wheel on a bench grinder,
Drizzy.
and the thread we need to machine is 1.5 by 8. And the thread we need to machine is 1.5 by 8. Oh fuck, I did it again. So the drive slots have to be exact. So so that's our longer extension completed. Now we just need to machine the slots in the 2 little ones. So that was really quick and easy. An alternative way of doing this would be to be used. Brain's like the wire going.
Okay, come on.
Right. Where had to start? Oh wait, what'd you say? So that was quick and easy. Now we can
This ain't quick or easy.
Wait, what?
That was awkward as.
I know.
There we go. Oh. So that's that little bit there you got to thread.
Yeah.
Yeah, right. Oh.
Turn the fucking magnet the right way.
I thought it would stick. I wobbled it to test it.